A single-phase 3-wire connection involves loan, L2, and a neutral conductor. This configuration is commonly used to supply both 120 volts and 240 volts power from a single source. The neutral conductor serves as the return path for both loan and L2. The key principle is that the neutral conductor carries only the imbalance between the currents in loan and L2. In a balanced system where the current in loan equals the current in L2, the neutral conductor carries minimal current. However, if the loads on loan and L2 are unequal, the neutral conductor carries the difference. For example, if loan has a load of 20 amps and L2 has a load of 10 amps, the neutral conductor will carry 10 amps, which is the difference between 20 amps and 10 amps. This connection is generally safe and efficient as long as the neutral conductor is properly sized to handle the maximum possible imbalance. Now consider the scenario where two loan loads are connected to a single neutral conductor. This configuration is dangerous because the currents from both loan loads add up in the neutral conductor. Suppose you have two loan loads, each drawing 10 amps. In this case, the neutral conductor would carry a total of 20 amps. If the neutral conductor is not rated to handle 20 amps, it can overheat, potentially leading to a fire or electrical shock. The fundamental reason this is unsafe is that the neutral conductor is no longer carrying only the imbalance between phases, it is carrying the sum of the currents from multiple loads on the same phase. This can easily overload the conductor, especially in residential or commercial settings where multiple circuits may share common neutral. The only exception to this rule is when loads are on different phases, such as one loan load and one L2 load sharing a neutral. In this case, as discussed earlier, the neutral carries the difference between the currents, which can be managed safely. However, it is crucial to avoid connecting multiple loads from the same phase to a single neutral conductor. To ensure electrical safety, it's important to adhere to the National Electrical Code, or NEC, which provides guidelines for proper wiring and conductor sizing. The NEC addresses shared neutral conductors in various sections, emphasizing the need for proper overcurrent protection and conductor sizing to prevent overloading. Specific sections within the NEC, such as Articles 210.4, 215.4, and 300.13, provide detailed requirements for multi-wire branch circuits and neutral conductors. It is essential to consult these sections to ensure compliance and safety in electrical installations. When designing electrical circuits, it is also important to consider voltage drop. Voltage drop occurs when the voltage at the load is lower than the voltage at the source due to the resistance of the conductors. Excessive voltage drop can cause equipment to malfunction and can also lead to overheating of conductors. To minimize voltage drop, it is important to use conductors of adequate size and to keep the length of the circuits as short as possible. In addition to conductor sizing and overcurrent protection, proper grounding is essential for electrical safety. Grounding provides a low impedance path for fault currents to return to the source, which helps to trip overcurrent devices and prevent electrical shock. The grounding system should be properly installed and maintained to ensure its effectiveness. Another important consideration is the use of ground fault circuit interrupters, or GFCIs. GFCIs are designed to detect small imbalances in current between the hot and neutral conductors and to quickly trip the circuit, preventing electrical shock. GFCIs are required in many locations, such as bathrooms, kitchens, and outdoor areas, where there is a higher risk of electrical shock. When working with electrical circuits, it is always important to follow safe work practices. This includes de-energizing circuits before working on them, using appropriate personal protective equipment such as gloves and safety glasses, and following lockout/tagout procedures to prevent accidental energization of circuits. Furthermore, it is essential to have a thorough understanding of electrical theory and to be familiar with the National Electrical Code. If you are not qualified to work on electrical circuits, it is best to hire a licensed electrician to perform the work. The dangers of overloading a neutral conductor can lead to significant consequences, including overheating of the conductor, which can melt insulation and cause a fire. Additionally, an overloaded neutral can create voltage imbalances in the circuit, which can damage sensitive electronic equipment. In some cases, an overloaded neutral can also cause the ground fault circuit interrupter to trip, interrupting power to the circuit. To prevent these problems, it is important to carefully calculate the load on the neutral conductor and to ensure that the conductor is properly sized to handle the maximum possible current. It is also important to regularly inspect electrical circuits for signs of damage or overheating and to address any problems promptly. In summary, while a single-phase, 3-wire connection with a shared neutral for loan and L2 is a standard in safe practice, when the neutral carries only the imbalanced current, connecting multiple loan loads to a single neutral is a dangerous configuration that can lead to overloading, fire hazards, and electrical shock. Understanding these principles and adhering to the NEC guidelines are crucial for ensuring electrical safety in any installation. In addition to the specific dangers of overloading a neutral conductor, it's important to recognize other common electrical hazards and how to mitigate them. Firstly, improper wiring is a significant cause of electrical fires and shocks. This includes using the wrong gauge wire for the circuit, making loose connections, and failing to properly insulate wires. Secondly, damaged or frayed electrical cords can also pose a serious risk. Over time, the insulation on electrical cords can become brittle and crack, exposing the bare wires. Touching these wires can result in a shock, and the exposed wires can also create a fire hazard. Thirdly, overloaded circuits are another common cause of electrical problems. When too many appliances or devices are plugged into a single circuit, it can overload the circuit breaker or fuse, causing it to trip. Repeatedly overloading a circuit can damage the wiring and create a fire hazard. Fourthly, water and electricity are a dangerous combination. Never use electrical appliances or devices near water, and always make sure that electrical outlets and switches are protected from moisture. Fifthly, using extension cords improperly can also be hazardous. Extension cords are intended for temporary use only, and they should not be used as a substitute for permanent wiring. When using extension cords, make sure that they are properly rated for the appliance or device being used and that they are not overloaded. Sixthly, neglecting to maintain electrical equipment can also lead to problems. Regularly inspect electrical appliances, devices, and wiring for signs of damage, and have them repaired or replaced as needed. Seventhly, working on electrical systems without proper training or knowledge can be extremely dangerous. If you are not qualified to work on electrical circuits, it is best to hire a licensed electrician to perform the work. Eighthly, failing to use ground fault circuit interrupters in areas where there is a risk of water exposure can also be a serious safety hazard. Ninthly, tampering with electrical meters or other utility equipment is not only dangerous but also illegal. Tenthly, ignoring warning signs of electrical problems such as flickering lights, sparking outlets, or burning smells can allow small issues to escalate into major hazards. Always investigate and address any electrical problems promptly. In addition to these common hazards, it's important to be aware of specific risks associated with different types of electrical equipment and installations. For example, swimming pools and hot tubs require special electrical precautions to prevent electric shock. This includes using ground fault circuit interrupters, bonding all metal parts together, and ensuring that electrical equipment is properly grounded. Likewise, electric vehicles and charging stations require specialized electrical installations to ensure safe and reliable operation. This includes using dedicated circuits, proper overcurrent protection, and appropriate wiring methods. Renewable energy systems such as solar panels and wind turbines also require careful attention to electrical safety. These systems typically involve high voltage DC power, which can be particularly dangerous. It's important to follow all applicable codes and standards when installing and maintaining renewable energy systems. Furthermore, it's crucial to educate yourself and others about electrical safety. This includes learning about the dangers of electricity, how to identify electrical hazards, and how to take precautions to prevent electrical accidents. Share this knowledge with family members, friends, and co-workers to help create a safer environment for everyone. In conclusion, understanding shared neutral connections and common electrical hazards is essential for preventing electrical accidents and ensuring the safety of yourself and others. By following safe work practices, adhering to the National Electrical Code, and educating yourself about electrical safety, you can minimize the risk of electrical shock, fire, and other hazards.